Alright, so in this lesson we're going to talk about signed and unsigned numbers. Now very briefly, a signed number means a number that can be positive or negative, and an unsigned number means a number that can only be positive. Now this lesson applies to all programming languages, not just C. Now we've already discussed that computers represent all data as binary. We also discussed that it is impossible to distinguish one data type from another just by looking at it, because any given sequence of binary could be part of absolutely anything. Maybe a number or text or part of a movie or anything at all, even a program. For this lesson, we are going to only discuss numbers. Now, let's examine the following binary number. Now, this number is, of course, 7. If I asked you to store that inside of your computer, what is the minimum size that you require? The answer is 3 bits. Each bit in your computer is effectively a single 1 or 0. And 3 of those bits will be big enough to store any value from 0 through 7. Alright, but what happens if you need to store the number 8? Well, you can't do that with only 3 bits. You need at least 4 bits because 8 is represented using 4 binary digits. And since 8 is represented using 4 binary digits, you need at least 4 bits in order to store the number 8. If you needed to store a number 16 or greater, you need at least 5 bits. So here we learn 2 very important principles. First of all, you can see that the number of bits determines the maximum size of any number. So if you only have 3 bits, you can't store a value greater than 7, and so on. Secondly, you see that just by adding 1 bit to the end of any binary sequence effectively doubles its capacity. So whereas with 3 bits you can store 8 different values, that's 0 through 7. With 4 bits, you can store 16 different values, 0 through 15, and every time you add a bit, you double how much can be stored. So I want to explore this a bit more so that you can understand something about binary at a fundamental level. Let's look at a sample table of binary numbers. Now we start at 0 and we go all the way to 7. Now if we start at 8 and continue, we have a second table that you see to the right. And finally at 15 we're done. So between 0 and 15 we have stored a total of 16 different values. Now did you notice that we simply repeated the first table of 0 through 7 a second time, but with a 1 in front of it, whereas over here we have a 0 in front. This is because the 1 on the far left over here effectively means add 8. So any number over here, if we change the 0 to a 1, we add 8. We could also do something else here if we wanted to. We could choose to say that both sequences are counting from 0 to 7, except we could say that the far left digit, right here, is a flag indicating if we want the number to be positive or negative. We could choose to say that instead of an 8th place, this 4th column from right to left means positive or negative. we could say then that if it's set to a 0, it means positive, and if it's set to a 1, it means negative. Whenever you encode a number in binary in such a way that it can be either a positive or a negative number, that is known as a signed number. This specific method that I am introducing is known as signed magnitude. It basically means that the furthest digit over to the left is a flag indicating whether or not the number is positive or negative. So for example, this is positive 3 and this is negative 3. Whenever you define a bit as a flag for stating if a number is positive or negative, that bit is called the sign bit. In this case, a sign bit of 0 means positive number and a sign bit of 1 means negative number. Now here you should notice something important. When you are using 4 bits, if this were an unsigned number, we could count all the values from 0 to 15. However, when we make the 8's place into a flag for positive or negative numbers, we can only now count half as much as before, but we can do so in 2 different directions. So we can count from 0 to 7, and then we can count from either we can say from 8 to 15, or we can say from 0 to negative 7. Now remember that this is a system we are just using for the purpose of this lesson. I'm not saying that this is the best way to represent positive and negative numbers. In fact, you immediately notice a problem, which is that we're effectively saying 0 twice, which seems that we are not doing things as efficiently as we could. But we'll get into that in a later lesson. I want you to understand the concept of using a sign bit to indicate a positive or a negative number. So I want you to get 3 things out of this lesson. Okay, so first of all, you learned that you can specify a number as being negative or positive using a sign bit. And a sign bit is simply a binary place value that, rather than having a numeric value like, say, the 8's place, it is rather an indicator of whether or not the number is positive or negative. Secondly, when you have a sign bit, you can only count half as far, but you can do so in 2 directions, positive and negative. And last, the same exact binary can encode a signed number or an unsigned number. For example, the binary sequence 1010 could mean 10, or it could mean -2. Keep in mind, it is up to you, the programmer, to specify how any given binary sequence is going to be interpreted. You might be asking yourself, okay, so how do I know whether it is a signed number or an unsigned number? And I'll show you exactly how to do that in later lessons, but I want you to get a feel for the idea that you get to decide these things as the programmer. You might come up with a totally different method of storing values in binary, and you might decide that a given place value is numeric, another place value is a flag for some purpose, but the point is you get to decide these details. So in this lesson, I've introduced you to signed and unsigned numbers, and I've shown you one method of using binary sequences along with a sign bit in order to represent signed numbers and unsigned numbers. We'll explore this more in later lessons, but I want you to remember that a signed number is a number that can be positive or negative. And in order to be positive or negative, there has to be a flag, a sign bit, which can be set to 1 or 0 to indicate whether the number is positive or negative. And secondly, An unsigned number has no sign bit, and rather every binary digit has a numeric value, which means that you are limited only to positive numbers.